Hello everyone, welcome to the session on geniuschalk. Today we will be discussing part 5 of HCF and LCM. So let's start with the first question. First question says, two cogwheels having teeth 48 and 72 respectively, the bigger wheel make 28 revolutions per second. How many times the specific peak of the bigger wheel meets the specific peak of the smaller wheel in 20 seconds? What is cogwheel? Cogwheel is something like this. Say this is a smaller one, so the bigger one will be say of this size. So the first one, which is having 48 teeth, obviously will be the smaller one, and the bigger one having 72 teeth. This is the bigger one. Now, what is given that this bigger one is making 28 revolutions, and they both are connected. So they both are moving together actually like this. So this specific peak of this bigger one will touch the smaller one. This is what it is asking, how many times the bigger wheel will meet the smaller wheel in 20 seconds. So first of all, we have to find that if it is given that this is 28 revolutions is made by the bigger wheel, that means 28 revolutions are taken by bigger wheel in per second. So bigger wheel is having 72 teeth. So smaller wheels we have to find. Let's say it makes n number of revolutions. So it will be 12 6 are 72, 12 4s are 48, 4 7s are 22. That means it is 42. It is 42. That means the smaller wheel is making 42 revolutions, while the bigger wheel is making 28 revolutions. So first thing we have to find this. Afterwards, we have to find that what is the LCM of both the revolutions in seconds. So if you say the first one is making 28 revolution in 1 second, so one revolution it will make in 1/28 of the second. Another one, if it is making 42 revolutions per second, in 1 second 42 revolution, so one revolution will be taken by 1/42 seconds. So first let's catch what is the time in which both the revolutions will be done. So it will be LCM of fractions will be found by using LCM of the numerators, that is 1, and HCF of 42 and 28, which are the denominators, that is 1/14. That means LCM is going to be 1/14. That means what we can say, that they will meet in 1/14 of the second. That means we can say in 1 second they will meet 1/14, right? In 1 second they will meet 14 times. So they say in 20 seconds how many times they will touch each other. So it will be 14 into 20, that is going to be 280. That is my option D, right? But this is a good question, important question. What we have done, we have made the number of first we have found the number of revolution of the smaller one. Afterwards we have found the time in which both of them will meet in one revolution, time wise in seconds. So it is 1/14 of a second. So one revolution they will meet 1/14 of a second. That means in 1 second they will meet 14 times, right? So in 20 seconds it is asked, so they will meet 14 into 2, 28, and 10, 280 times, right? Let's move ahead. The smallest square number divisible by 10, 16, and 24. What is 10? 10 is 2 into 5. It is 2 to the power 4, and this is 8 into 3. First we have to find the number is divisible by all of the 3. That number must be the LCM. Now what is the LCM? If you take the LCM, it is highest power of 2, that is 4, then highest power of 3, that is 3 only, and highest power of 5 is 5. So we can see it is saying smallest square number. We can see what is a perfect square. A perfect square is a number which is having its power even. So here its power is odd. That means we need to multiply with one more power of 3, and we need to multiply with one more power of 5. So if we solve this, this is 16 into 3 into 5 into 15, right? So this becomes 48 into 5 into 15. So that has to be our answer. So 40, 5 4s are 20, 240 into 15, that is 15 4s are 60, 15 2s are 30, and this is 3600. So this is checking your concept clarity of perfect square. So these values, these powers were not even, they have to be even. For them to be even, we have to multiply this complete number by 3 into 5, and that's how we can find the smallest perfect square. So answer is 3600. Let's go to the next question. The least number of 6 digits divided by 4, 6, 10, 15, leaving in each case the same remainder 2, and it is asking the sum of the digits. So first we know we have to find the LCM of this. So it is 4, 6, 10, 15. Read the table of 15. 15 2s are 30, 15 4s are 60. That means 60 is a number which is cancelled by all. So the number will be of the form 60 into k plus 2, because 2 remainder has to be there. This will be the form of the number. Now the number has to be of 6 digits. 6 digits, right? So what we have to do is 6-digit number is, if you check with the least value of k, that is 1. So let's check with the 2. This 60, suppose let's check with 60 first. 2 will add in the last. So let's check it. What is the least number of 6 digits? So this is 1 0 0 3 4 5 6. If you check with by 60, 60 1 the 60, 4 0 0, 66 the 360, that is again 4 0 and one more 0, that is 60, that is 4 0 and 0, that is 360, that is 40. Right, now leaves in each case a remainder 2. The sum of the digits is in n, that is, now you see we are having a remainder of 60. So we know how to find the smallest digits. Add the difference of both, or you can do like this also, that 1 lakh minus 40 will be, this is 60. Now get the next multiple. So this will be 1 lakh 20, or you just add in 1 lakh plus the difference of divisor and remainder. This we have done in number system videos as well, you can check it out. So 1 lakh 20 is what we are getting, and it's saying now 1 lakh 20 is a number which is leaving 0 remainder, right? But what we need as the remainder, is 2. So that means we have to write it 10022, and that is 10022, that is the sum of digits is asked. So 2 plus 2 plus 1, that is 5. This is one method which we can solve using this, and except this we can have this method as well, that the number will be of the form 60n plus 2, right? This number has to be divisible by 4, 6, 10, 15, whose LCM is 60. LCM is 60. In 60, basically this 5 comes, 4 comes, and 3 comes. Now let's check in 1 lakh. What is the problem? In 1 lakh, it is divisible by 5. It is divisible by 5 as well as divisible by 4 also, as the last 2 digits are divisible by 4, but it is not divisible by 3. So how can we make this number divisible by 3? We can make, if I add 2 here, but the problem is it has to be divisible by all of them as well. If I only add 2, it will become like this 1 lakh 2. It is not divisible by 5 4s are 20. So in order to make this number divisible by 20, what I need to do is, I have to add 20 here, because now 5 4s is 20, and now we can see the sum is coming out 1 lakh 20, that is 1 plus 2 3, right? 1 plus 2 3. So this number is divisible by 5 also, 4 also, and 3 also, but this is divisible properly. We need to have remainder 2 as per the question language. So we need to have remainder 2. So just add 2 here, and that is 100. So this is the shorter approach. How we can get it? Like you see, this is LCM is coming out to be 60. which is having factors 5, 4, 3, and to get this 1 lakh divisible by 5, already divisible by 5 and already divisible by 4, but in order to get it divisible by 3, we need to have 20 here, right? Then only it is divisible by 5 and 4 also, and totally, because the sum of the digits is 3, it is divisible by 3 also. So 1,20,000 is absolutely divisible by all of these, but we need to have remainder 2 also as per the direction of the question. That's why we need to add 2 here, and the final answer is 1,22,000, and that is going to be 2 plus 2 plus 1, and the sum is going to be 5. This is how we will use the divisibility concept in HCF and LCM questions. Next question is the least multiple of 7, which leaves the remainder of 4, divided by any of 6, 19, 15 and 18. So what is the least multiple of all of these? That is 90, and it is k plus 4. This number must be of this form, right? And before that, we can just check the option and solve our answer. If I put the value of k as least as 1, I'll be having 94. Let's check whether if I divide 94 by 7, is it leaving a remainder of 4? It will not, because 13 7s are 91. So it will be leaving a remainder of 3. It is not my answer. Yes. And second thing, we need to have least multiple of 7. So if I check the option, this is not a multiple of 7. It is not a multiple of 7. Only this option is a multiple of 7. So this has to be my answer. Technically, we can prove it just by using the values. So if I put k as 4 here, because 94s are 360, only this option is coming to close, that is 364, and that is going to be my answer, right? Next question. The least number which when divided by this leaves in each case the remainder of 2, but when divided by 22 leaves no remainder. So let's find the LCM of 3, 5, 6, 8, 10, 12. So if I write 3, 5, 6, 8, 10, 12, the LCM will be 120, right? It will be 120. Reading the table of 12 10 times. So the number must be of this form, 120k plus 2. And now this complete number has to be divisible by 22. It should not leave any remainder. Now, just use the divisibility concept. If I need to divide this number by 22, it will be 22 5s are 110, and 10k will be left. So this number will be of this form, 10k plus 2. Right now, this form has to be divisible by 22. That means what is the least number by which it should be divisible? That has to be 22, or that has to be 44 and 66 and so on. But the least number is 22. Tell me what should be the value of k if this number should be divisible by 22. So this is 20, so k has to be 2. That means if I put k here 2, I will get my answer 120 into 2 plus 2, 240 plus 2, that is going to be 242. 242 has to be my answer, right? This is the approach of this type of questions. The product of LCM and HCF of two numbers, LCM and HCF of two numbers is 24. The difference of the numbers is, let's say A and B are the numbers, the difference is 2. Find the numbers. If there are two numbers whose HCF and LCM are given, we know that the HCF and LCM are always equal to the product of two numbers as well. So we have basically two equations. So which values I should put? Just use the option. If I use the first option as 8 into 6, that is giving me 48. Here it is 24. That means this is not my answer. 8 and 10, if I use, that is giving me 80, which has to be 24. That has to be my answer. And obviously A minus B also has to be 2. So this was 2, but it is not satisfying the product rule. 8 and 10, 80, it is not coming out to be 24. 2 and 4 is not 24. All three are cancelled. 6 and 4, if you check, 6 and 4, that is 24, and 6 minus 4 is 2. That means option D has to be my answer. Let's move on to the next. HCF and LCM of two numbers are this. One of the number lies between 75 and 125, then that number has to be what? Let's decide. So HCF and LCM are this. So if HCF is 13, that means the number must be of 13A and 13B form, as HCF is always present in both the numbers, and the product of two numbers must be equal to their respective HCF and LCM. So 13 is cancelled out. If you cancel it, 13 3s are 39. So this will coming out AB as 35. Now we know that this AB we have to put so that they both are co-prime to each other. Now what is co-prime? The product of the numbers or the numbers whose HCF in pairs is 1. That is co-prime. So that means this is A and B. So first value I can use is 7 and 5. That is 35. And second value I can use is 1 into 35. That is also 35. These two cases we can see that the number is co-prime. Now 7 and 5, that means this value will be what? One hint is already given, that this number must be lying between 75 and 125. So we can use this. So if I keep this here, 13A and 13B, 13 into 1, the first number, 13 into 35. So this number will be a more than 125. If you put it 13 5s are 65, 13 3s are 39 plus 6 45. So this number will be 13 and 4 55, and it is saying one of the number lies between 75 and 125. Here you can see one of the number is 13, which is less than 75. Another number has to be between 125 and 75, but it is more than 125. So this pair I cannot take. So I can take only this pair, that is 7 and 5. So just put the value 13 into 7 and 13 into 5. This is becoming 91 and this is becoming 65. It is saying that number is like one of the number which is present in the option. So in the option we can see 91 is present, 65 is not present. So that has to be my answer. So let's move on to the next question. The ratio of two numbers is 2:3 and their LCM is 54. This question I have shared in the shorts video as well. 2 and 3, that means the numbers are of this form, 2A and 3A, as the ratio is given. Their LCM is 54. As per this, what should be the LCM? 2 into 3, 6 and A. But actual LCM is 54. That means A value has to be 9. If A value has to be 9, that means I can say the first number has to be 18, second number has to be 9, 3s are 27. This has to be the number. It's saying the sum of the two numbers, so this has to be 45, which is answer option C. Right, next one. The HCF of two numbers is 23. The two factors of their LCM are 13 and 14. So HCF is 23. That means numbers are of this form, 23A and 23B, right? If other two factors of LCM are 13 and 14, that means what has to be my LCM? Has to be first it has to be 23 also. Then because of this A and B, there must be some other factors coming in picture, and those two factors are already given as 13 and 14. That means this has to be my answer. This has to be my LCM, right? So now I know that this is the LCM of these two numbers, 23 and A and B. Now I have got the LCM. Now let's figure out what has to be the bigger one. So one of the number has to be, let's say, 23 into 13. Another number has to be 23 into 14. Now let's see which option is available for the answer. 13 3s are 39, 13 2s are 26, and 3. Yeah, this option is present. Let's check it out. 14 3s are 42, 14 2s are 28, plus 4 32. So it says the larger of the two numbers. So the larger of the two numbers is 322. So this is not my answer. Option D has to be my answer. I hope you have got this concept, why I did like this for LCM, why I did like this. because it is A and B, and that means this A and B must be none other than these numbers only, A and B, because 23 is HCF, that means that is present. These different numbers are co-prime, that's why they are coming in the LCM, right? Like if I say 6 and 10, what is the LCM? You will say it is 2 into 3 and it is 2 into 5. So you can see HCF is 2, but this 3 and 5 are coming. So LCM will be 2 into 3 into 5, right? That's why this 2 was already the HCF, but 3 and 5 had come in the LCM part. They were other factors of the given numbers. That's why I have taken. So one of the number is 23 into 13, that is 2 into 3 like, and another is 20 into 14, that is 2 into 5 like. I hope you have got the concept. Next question. The numbers both greater than 29 have HCF 29 and LCM this. Find the sum of the two numbers. Let's find it. So two numbers both greater than 29. This is what we have to make sure. Fine. HCF is 29. The numbers must be of this form, 29A and 29B. And we know the product of the two numbers are always equal to their respective HCF and LCM. That means I can say it is equals to 4147. 29 gets cancelled. 29 must cancel this. So if you cancel this 4147 by 29, it must cancel. 29 ones are 29. It is 1 to 4. 29 threes are it should be 6 to 8, not going. 29 fours are 116. 29 fives are 35s are 150, should be 145. So we can go with 14, that is 116. So 87, 29 threes are. So this is coming out to be 143. That means the product of two numbers has to be 143. Now how can we have two numbers product 143? This knowledge you must know that 143 has factors 11, and I guess 13 as well. Yeah. So if we can write it AB, two numbers has to be co-prime. So one is obviously 1 into 143, right? As both are co-prime to each other. Another has to be 11 into 13, right? So sum of the two numbers is asked. So one of the number has to be 1. It was 29A, so it has to be 29 into 1, as this is 1. Next has to be 29B, so 29 into 143. And you can see that this value, if you take this 30 also, 140 into 30, this will be more. This will be very high, right? If you even solve it, let's say 29, and say this is 29 into 143. This will be a higher value. Then this sum will be crossing the limit, because it is like, suppose you take this 140, this is 4200. So 4200 is not in this option. Like this answer will be little less than this, but it will be of 4 digits. That's why I have to cancel this 29A and 29B part. Right now, this has to be 1 and 143. So this has to be 11 and 13. So my answer has to be 29 into 11 and 29 into 13. Now, in order to add it, if I take 29 common, 11 plus 13 has to be 24. So the last option should be ending with 6. There are 3 options. Let's multiply better. If you take this 30 into 24, that is 720. Subtract 24 from here, so it has to be 696. All right, the next question is LCM of two numbers is 495 and HCF is 5. So if HCF is 5, we can take the product as 5A and 5B, that is equal to respective HCF and LCM. So 5 is cancelled. This is 5 9s are 45, 5 9s are 45. So AB has to be 99. If AB has to be 99, that means these two numbers has to be co-prime. So this is 1 into 99, or it is 9 into 11. So if you take the difference here, the difference is 98 and 5 is common. Like the number will be 5 into 1, another is 5 into 99. If you take the difference, 5 is common. 99 minus 1 is 98. The difference is not present in the option. That means the answer must come from this pair only. So what is the difference here? It is 2. And what is the HCF in both cases? It is 5. So the difference between them has to be 10, which is my first option. Or I can find like this: 5 into 9, 5 into 11. If I take the difference, 5 is common, 11 minus 9, that is 2. So option A is the correct answer. Let's solve the next one. It says the two numbers both greater than, this is the same question that we have just done before, this one. So we'll not solve it again. Next question. HCF of two numbers each having 3 digits is 17. So two numbers each having 3 digits is 17. So it is 17A and 17B. Their LCM is 714. That means that must be equal to respective HCF and LCM. 17 is cancelled. So 17 4s are 68. So this AB has to be 42. AB has to be 42. That means AB has to be co-prime. Let's find it co-prime numbers. It is 6 into 7 and 1 into 42. So most probably our answer must come from this part, as this is very big. So 17 into A. The first number must be 17 into 6. Second must be 17 into 7. If I need to take the sum of this, take the 17 common. 6 plus 7 is 13. 3 7s are 21. This could not be my answer, as the last digit is not 1. So 13 7s are 91. 13 1s are 13 plus 9 to 21. Option C has to be my answer. Let's solve the next one. Find the largest number of 4 digits such that on dividing this by 15, 18, 21 and 24, the remainders are 11, 14, 17 and 20. Now, we know first we are having 15, then we have 18, 21 and 24. The remainders are 11, 14, 17 and 20. We can see the respective difference between all of them is 4. So this is that type which we have discussed already, where the difference between the divisor and the remainders are these, right? Now if the difference is same, what was the approach? Whatever is the LCM, we first need to find the LCM, and then we subtract this common 4 from there, and that was the answer. Now let's find the LCM first. Largest number of 4 digits, then we will divide it by the largest number of 4 digits. So what is the LCM of 15, 18, 21, 24? Okay, let's find it. Remember, we have to subtract 4, huh? So let's find it. 3 into 5, 3 square into 2, 3 into 7, 2 cube into 3. So what is this? Highest power of 3. That let's find for 2 first. 2 to the power 3 is the highest power of 3. Then 3 to the power square is the highest power. Then 5 is there. Then 7 is there. Yeah. So let's find the LCM. This has to be the LCM. This is 8 into 9 into 5 into 7. This has to be 72 into 5 into 7. This has to be 360 into 7. So this is my LCM first. So what is that? Let's find it. 0, 36, 7. 30 into 7, 210 and 42, 520 is my LCM. So first I have got the LCM as 2520. Now I'll check this. I'll divide the largest number of 4 digits by this. So if I check this, it will not go 4 times, it must go 3 times. Let's see. 23 is 60, it is 7560, and this is 9, this is 3, this is 4, this is 2. The remainder. So basically just subtract this remainder from here. If you subtract this 7560 only, so 7560 is a number which is completely divisible by 2520. But as we have discussed, we have to subtract 4 also. Respective divisors and the remainders have a difference of 4. So subtract 4 from there. 7556 has to be our answer. That is option B. The next question is find the least multiple of 23 which when divided by 18, 21 and 24 leaves the remainder 7, 10 and 13. Now let's check 18, 21, 24 leaving the remainder 7, 10 and 13. The remainder, the difference between the divisors and the remainder is 11. So we have to subtract 11 after taking the LCM of all of these three. Now let's take the LCM. 18, 21 and 24. It is 3 square into 2. This is 3 into 7. This is 2 cube 8 into 3. Now this is let's take the highest power, 2 की power 3. This is 3 का square into 7. So 8 into 9 into 7, that is 504. So the answer must be 504k minus 11. This 11 was the difference in the respective divisors and the remainders. So this has to be 50k minus 11. So let's find it. 50k. What is this k? K has to be you see this is 30, so this is 5. So if I multiply this by 6, I will get closer to 3000. So this is 30, 24 minus 11, that is 3013. So that is option A. Option A has to be my answer. So this is how we can solve this. All right, next question. The greatest number of 4 digits divisible by 12, 16 and this, leaving the remainders 2, 6 and 14. 12, 16, 24. It is 2, 6 and 14. Respective difference is 10. Fine. So LCM minus this. So find the LCM. 12, 16, 24. 12 is 3 into 2 square. Next 16 is 2 to the power 4 and 24 is 2 to the power 3 into 3. So 2 to the power 4 into 3. So it is 48. 24 to the 48 also we can find it. So 48 is the LCM and the number must be of the form 48k minus 10. 48k minus 10. But here it is greatest number of 4 digits. Greatest number of 4 digits. Fine. So let's find the multiple of 4 digits for 48. So after this, let's remove this all. So 48 was the LCM. Greatest number of 4 digit is 4 times 9. 48 2s are 96, 3, 9, 0. Now 48 7s are 7 8s are 56 and 28 plus 5. 28 plus 5, 33. If you check 48 8s are 64, 384. Yes, we can go one step ahead. So this will be cancelled by 8. So this is 384, 5, 1. So 15 is left. 15 is left. Subtract 15 from here. If you subtract, it is 49984 has to be the number which is leaving 0 remainder. But remember what we have learned. We have got the difference here as 10. So subtract that 10 also. So this is my answer, 9974. The other way to solve this question is, again you can check the options and check each option is divisible by all of them. So that, like if you check 12, this number will be divisible leaving remainder 2. This how you can solve this question in exam very fast. Like I've just discussed before also. Again I'll try to discuss, like 12, divide this number by 12. 12 8s are 96, 3, 7. 12 3 36, 1 4. So 2 is the remainder. You can see 2 is the remainder. So, and this is the highest. No, this is not the highest. So we can check the highest first. So yeah, this has to be the answer, of course. This 12 8s are 96, 3, 9, 3, 8 is left, and 12 3 36, 2 remainder is coming, and this is also giving us 2 remainder, right? But if you check by 16, 6 are 96, 3, 9, 16 to the 32, so 78. 78. 16 4s are 64. It is giving us 14 remainder. So with 16, it is not giving us 6. It is giving us 14 remainder. So this cannot be my answer, right? And this 74 is obviously we are getting the answer by using this 12 in this. So this has to be my answer. But because highest was also given, so I have checked the highest number more than this. Except there is no need to check. This is the highest number. After this, so this has to be my answer, right? So thank you so much for watching. That's all for the session. God bless you all.